Hi, you hear me? Great. So, I want to start by saying that I'm very excited to be here, and I truly believe it's a privilege to speak in front of so many talented iOS developers. And you know, when I built this session, I wanted to know how many iOS developers are in this crowd, in this conference. So one option is to count you one by one, but I'm too lazy for that, so I'm not going to do that. So I did something different. I built an app that counts people, and I gave it some very, short and catchy name. It's called Conference iOS Developers Crowd Counter. It's going to be a hit in the App Store, and I want to show you how it works. Now, the trick with this app that it only counts iOS developers, not normal people, And the way it does it is that, every iOS developer has an Xcode, right? And in Xcode, you've got code signing, and we love code signing, right? It's amazing. And it makes us smile. So iOS developers usually smile because of this code signing. So I'm going to show it how it works right now, and you need to smile because you're iOS developers. This is what you do. So I'm taking a picture because this is wide audience. I'm going to take one picture here. You see? 64 people. And here, amazing, 68. So we've got around 130 people in the crowd. This is amazing. It's actually as developers, not just people. That's a good, but I have the system knows because of the smile. Now, so I lied about the smile. Okay, it doesn't really detect if you smile. I'm going to talk about this app by the end of the session so you understand the challenges that we have in building this app that can also recognize smiles, okay? Obviously, this app uses some kind of a machine learning, and I want to clear some things up about what is a machine learning because, not every iOS developer knows exactly what are the definitions of the different terms in machine learning and AI. So the first thing that we need to know that machine learning is not AI, okay? These are two different things. They are related, but it's not the same. And the second thing is that AI is not Apple intelligence. I'm sorry, Tim. Please don't block my Apple ID. So that's one of the things that we need to understand, because AI is a technique that enables machines to solve tasks like humans. Now, ChatGPT is a great example for an AI product. And machine learning is just a subset of that. Okay, it's what makes machine learn from history of data. Now, another subset of that is neural network. Neural networks is the way our brains think. So it's a brain-inspired algorithm and learning models. And of course, deep learning, if you heard of this term, is just a fancy name for neural network with many layers. Now, some of you may know that, and that's fine, but many as developers don't know that. And a question I ask myself, where do I as developers stand with machine learning? And the answer is, well, not so good. The first reason is that if you look on the different fields in software development today, you see design, front-end product. On the other side, it's server, data, math. And, well, as developers are located somewhere between product design and front-end, which is UX and Swift UI. Design because we are as developers. Android developers, well, less design, I guess. And on the other side, math and data, we've got machine learning experts. Now, you can see the gap between us. But you know what? I don't buy that. We can do so much great things with machine learning on iOS. For example, we can enhance search capabilities. We can provide insights. We can recommend great content. But each time an iOS developer reach out to the web and try to learn what to do with machine learning on iOS, they see only one use case, and that's cat detection. You know that? It's always about detecting cats. And that's insane, because if you don't believe me, just Google it. There are hundreds, thousands of blog posts about how to detect cats. Now, I haven't seen any, app like Cat Detector, which is, I don't know, understand why you have so many articles about detecting cats. So I decided, no more detecting cats. I don't know what they did to us, but we need to finish with that. So, what are we going to detect? Something much, much better than cats. Dogs. No, I'm kidding. Much better than cats. Candies. Okay, we are going to detect candies. We're going to build an app that works with candies. Now, candies are much better than cats because, for example, you can eat candies. You cannot eat cats. It won't scratch you. It fits in your pocket. Well, there are cats that can fit in your pocket, but we are not going to talk about them. And then you jump on your catboat, and like cats, you can cuddle with them in bed. So we are going to build some app that's called My Candy Snap app. It lets you log your candies. It can identify different candies. You can log their history. You can do so many things about it. And the first thing that we need to do in order to start building the app is using the Vision Framework API. Now, the Vision Framework API, personally think, is one of the most sophisticated SDK that Apple offers. It's also very, very simple. What you see here, the list of text detection, object tracking, image analysis, is only tip of the iceberg of what you can do with the Vision Framework. There are almost 30 different features that you can use. And it's very, very simple API compared to how it's sophisticated. Each one of these features represented by an API structure, okay? So, for example, for text detection, you've got a request, detect text rectangle request, or image analysis, classify image request. So you start by building the request, and then you send it to some ML model that we're going to talk about it in a few minutes, and then you get some observation. Here's a snippet, code snippet of how it works. First, we pull out the CG image from the image because we don't want, Apple doesn't want the Visual Framework to be dependent by the UI kit. We create a request. We call the perform function with the CG image from earlier, and then we analyze the results because we get different results. For example, if I take a picture of this table, I get a cup, a table, a laptop, and a phone. So there are some problems with that if we want to build our amazing Candies Snap app. The first thing is that, well, potato chips considered to be a food in the Vision Framework. That's a problem, not if you argue with my son. My son thinks it's a food. But we understand that it's a snack, it's a candy, it's not really a food. The second thing is that it classifies also other stuff, other objects in the image, and we want to focus solely on candies. And the third one is that it's only aware for candy. It doesn't identify or distinguish between Milka, M&M, Twix, Snickers, or whatever we want it to be classified. So that's a problem. And in order to solve that problem, we need to understand how detecting objects work in Vision Framework or in general with neural network. So how it works? Well, let's start by this image. If I ask you, what is this image? Most of you will say, that's a 7. That's a handwritten 7. And it's feel natural for all of you. That's fine. But it's pretty amazing that you can classify that as a 7, because a 7 looks like something like that, which is completely different. There is a line, horizontal line in between. The curve is not the same. The colors, the whites and the grays are different than the right image. So how do you do that? Are you so talented? First of all, yeah. But that's because you've been trained to do that from childhood. You saw thousands or tens of thousands of images of handwritten digits of 7 or letters. And that's what makes you so capable of watching a new image of a 7, of a handwritten 7, even if you never seen that before, you can still classify that as a 7. So how computer does do that? So first, the 7, as you can see, is just a bunch of pixels, right? It's not just an image. It's really a bunch of pixels. It's a bunch of data. And if we take all these pixels and put them in one row, okay? When each one of these pixels represent some value. For example, it could represent a value between 0 and 1. 1 when it's totally white, as in full, and 0 when it's black. And this line of pixel of this particular pixel is considered to be a neuron in our neural network. Now, what is the neural network that I'm talking about? Imagine that the left column is full with all the pixels of the image. And this is the first layer of our neural network. And we can build additional layers, okay? So the first layer, second, third, and fourth, but neural network can have up to 150, maybe 200 layers if you want to classify images. Now, all these layers are connected using weighted connections. Each one of these weight connections has a different value. At the beginning, it's a random values, but when we train the neural network, the values get fine-tuned. How does it work? Well, if we have, for example, 2 neurons with 2 values, 0.53 and 0.14, these are the values when we started with the network. These are the values of the pixels that I showed you before. And, well, I said that they are weighted numbers for the connection. So for the first one, is 314 is minus 217. This is all random, okay? At the beginning, it's all random. It doesn't really care about the value itself. What happens in the neural network that the data flows from one side to the other side of the network, and it's computed and along the way. For example, you can see the calculation here, and the values are being summed up to the next neuron on the next layer. So if we go back, yeah. So if we go back to the neural network that I showed you before, you can see that the values continue to flow inside the network. And at the end, we've got the final layer, which is the output layer. Each one of the neurons in the output layer represents a new class. What is a class? For example, sneakers or Twix. Okay, in the visual framework, we've got more than 1,000 classes. For example, a table, a chair, a person, a computer. So we, in our neural network, we want to have classes according to the different candidates that we have. Now, the problem with building a neural network like that is that it's really, really complex. It's really complex, and I want to show you why. Let's take an image of a candy. I think it's Twix or sneakers. I don't know. I think it's sneakers. Anyway, so that's an image of 100 pixels, which is not very big. Okay, we got images when we have thousands of pixels for each line, and we've got for each pixel we've got 3 values. We've got the RGB, right? It's not a grayed image. So if we want to calculate the number of inputs, we get to something like 3K inputs. Now, in a deep learning neural network, we've got something like 50 deep layers, at least 50 deep layers, with 512 neurons with each layer. This means that we go to 25,000 neurons, not considering the input layer, which is 30K. Now, if we try to calculate the number of connections between them, we get to 12 million weights. That's crazy, and that's only for 100 on 100 image. It's a lot of calculations. If we want to train that, well, we need something like 10K images for the training and 3 million input values. It takes few hours to 1 day to try to train such a network, and it takes something like 100 megabytes. Now, I know that we said yesterday that, okay, we can work with 100 megabytes model. That's fine. but that's only for 5 candies, sorry. Yeah, it looks like candies are demanding. And what about 5 candies or 100 candies? What are we going to do then? So, are we stuck with our app? What do you think we can do? So, there is a tool in machine learning that's called transfer learning. And transfer learning is something very, very cool. We take the neural network that we saw earlier, and you see the last layer, which is the output layer, which represents the different classes that we have. So I said that in the vision framework, we have now something like 1,000 classes. What we're going to do is we're going to select this layer, we're going to remove it, we're going to freeze the other connection or the other layers, and we're going to add a new layer, which only contains the different candies that we want, like Twix, Kit Kat, or M&M. Now, when we do that, what we can do is we can train only the last layer, while all the rest of the neural network is freezes. Now, transfer learning is powerful, and we can use CreateML to make it much simpler. So, CreateML is something that you have on your computer today, because if you have Xcode and code signing, so you also have CreateML. Now, CreateML comes with different templates, but for that I'm going to use the image classification. And the first thing that we need to do in order to use it is to have a data set, okay? So instead of 5,000 images, we can take a picture of a few candies, like 30, 40, 50 candies that we take a picture, and we can organize them in different folders. We don't have to use any CSV, any JSON, nothing. We can just drop them into folders, each folder with the name of the candy. We don't need to give special names to the images. You just drop them and you drag it into CreateML. And the first step is the training. With the training, what happens is that the neural network is being fine-tuned only the last layer. Okay, so all the weighted that you saw earlier are being fine-tuned and adjusted to meet the demands of the accuracy of the classification. The second thing is validation. With validation, with each round, we make sure that the training works as expected. And the third one is the testing. Testing is like the QA that we are doing for the neural network. Now, this process, instead of being a few hours, as I said, it can be something like 20 seconds, 50 seconds, depends on the number of images. But it's really, really easy. You know, 6, 7 years ago, Apple released the CreateML as a library that can only work on macOS, by the way, not on iPhone. But over the years, they released the CreateML app, which is very, very friendly and easy to use. Now, the next step is the preview. With the preview, you can test directly how the model works without implementing it in code. You can just take a picture, and that's it. You can see the results. And finally, the output, you can just, with one click, to send it to Xcode. It's really, really amazing as a developer experience, by the way, to work like that. So, how well did it learn? So you get some results or output results from the model. And the most important results, metrics, are precision. Precision is how accurate your positive prediction are. Okay, for example, if I take a picture of Twix, does it really classify as a Twix or something else? This is false positive. You want to detect false positive. The recall is the opposite. It's false negative. For example, if you've got 100 candies in your data set and you recognize 80, that's false positive. False negative, sorry. And these two metrics are important for us because it really depends on the use case. For example, if it's really, really important for you to not missing anything, for example, if it's a health app, okay, and you want to scan or analyze an image, it's really, really important for you, so you want a really, really low recall, okay? But if it's okay, then you can have a high recall, that's fine. And the same goes for precision. And the balance, the F1, what you see here, is the balance between these two values. Now, the next thing is we want to plug it into the app. Now, as I said, it's really, really simple. One tap on the create ML and it sends the model inside the app. It creates a file with the ML model extension, and it's put it in your app. And what EXO does, it generates automatically a class for you. So all you need to do is, like before, get the CG image, initialize the candy classifier, which is the name of the class, and then you initialize with the image, you call the prediction function, and you get the class back, which is the M&M in this case. Now, if you compare building from scratch and transfer learning, so we can see that the data set is much smaller, training time is 30 seconds, and the model size can be 90 kilobytes instead of 100 megabytes, because all the rest of the model is already inside the app, inside the SDK. Now, we said that CreateML works only on macOS. It doesn't work on iPhones. That's because of performance. But what about performance of trying to work with the new model that we just created? So let's talk about hardware for a second. A neural network can be something like 1.5 billion Mac operators. Mac operators is not Mac, okay, as you know it, is multiply accumulate. Is the actual mathematical operation that neural network needs to do. For example, 0.53 multiplied with 144 plus 1.108. This is what neural networks basically do. And in order to achieve that, if we go to the hardware for the SoC that we have, 818, we can drop it and see what's inside. We talked about the neural engine yesterday. And what's special about the neural engine that these types of calculations are optimized in the neural engine. It's very costly to do that on the main CPU or even on the GPU. But the neural engine has 16 cores, and each core has many Mac operation units. And all of these operations of calculation and adding are being done on the neural engine on the Mac operation units. And it's very, very fast and efficient. Now, I mentioned the crowd counter app at the beginning, and I want to talk about it now because I hope that I'm get that you're very curious how it works. So, how do we count people? The Vision framework has a specific request for detecting faces. Now, that can be an option. I can detect faces, but there are some problems with that. For example, when you need to detect faces, you need to have a high-resolution image to detect the nose and the eyes and the mouth. Now, that could be work for the first line or maybe the second line, but for those people that see in the back, it won't be good. And the second, that faces are not always visible. For example, if someone hides the faces of the man underneath, for example, you can see here in this image that most faces are not visible, and that can be a problem. And the third reason is that performance issues are a problem with face detection, because I can detect one face, but if you detect 200 or 300 faces, that can be a problem. So what do? We need a different approach. So neural network have the ability to detect or classify some patterns, like circles of the heads, or the shape of the person itself. Now, if you look on the right, you see the heat map of the density of the people for the image on the left. If you see red, that's a pixel that represents many people. So if we put it one on top of the other, you can see why it works like that. So what we want the neural network to try to build some heat map for the image. Now, it's also something that it's very, very complex to do. So what I did, I downloaded from Hugging Face, that was also mentioned yesterday. I downloaded a pre-trained model from Hugging Face. And this pre-trained model was based on what's called Shanghai Tech Crowd Counting Dataset. It's a dataset that contains more than 1,000 images of people, just crowded of people. And there were researchers in Shanghai that was sitting and really built heat map for each one of the images. Because the main problem with that is that you need the image, but you also need a heat map so the neural network can learn. So they built all these heat maps manually and counted these people manually. And this is what they put into the data set, and then we could train the model. Now, the problem with the model I downloaded from Hugging Face is that it was only the connection, only the weighted, only the parameters. It's not the actual neural network. So if you don't want to look, you don't have to. It's a Python code. And this Python code, what it does, it creates a neural network, rebuild the structure, implement the path, and on your left, you can see how we can convert that to a ML model, to Core ML. Now, the thing about Hugging Face is that you can find many Core ML models over there, but not always. But Apple provides what's called Core ML tools. It lets you take models that were built in different architecture and convert that to ML tools, so you can just drop it into your app and use them. So, in general, what happens in sessions that we do a recap of what we talked. But in this time, I want to talk about what we haven't talked. For example, there are other algorithms that you can use. For example, decision tree, linear regression, KNN. We haven't spoke about on-device personalization because you can take the model, for example, the 5 candies that we trained, and you can let the user add more candies on the run. This is something very, very special, and it can also use the technique of transfer learning. There are more visual framework features that I haven't mentioned. There are audio analysis, NLP, which can be very, very great of understanding text and enhance search capabilities. And you can also replace the model. Once you ship the app, you can push the model from cloud into your app bundle, which is also a very unique feature. Thanks, everyone. If you want, you can follow me on this account and questions.